Hello students. In our previous chapter on real number, we explored how numbers behave. We understood the concept like prime factorization, HCF, LCM, and the irrational numbers. That chapter gave us a strong foundation in understanding the nature and the properties of numbers. Now we are going to take a very important step forward. So instead of working only with the fixed number, we will start working with the variables and the expressions. Things like x square, x cube. This is where mathematics becomes more powerful because now we can represent patterns, relationship, and real life situations using the algebra. So welcome to the chapter 2, which is polynomials. So in this chapter, we will learn how to understand and form the polynomials, find their zeros, study their graphical representation, and explore the relationship between zeros and the coefficients. So this chapter is not just about solving equation; it is about connecting algebra with the geometry and developing deeper mathematical thinking. So let's begin this exciting journey from the numbers to algebraic expression. Thank you. So we'll start with this chapter. We'll firstly look at the agenda and then we'll start the discussion. Okay, so what we're going to understand in this chapter, we are going to quickly have an understanding as a recap from the class 9. We'll understand the geometrical meaning of zeros, graph of the polynomials, relationship between the zeros and the coefficients, how we can form a quadratic polynomial, zeros of the cubic polynomial. We'll cover the NCERT exercise coverage, and we'll also look at the CBSE question types, and we'll understand the practice strategy, and then we'll spend some time on understanding the key takeaways from this chapter. So let's move to the first slide. Okay. So we'll quickly have a recap from the previous class. We'll understand what is a polynomial. So polynomial is an algebraic expression made up of three different attributes, which is the variable. So variable like x, then we have the constant. So in a number we have a constant, and then we have a power to the variable. So three components of a polynomial are there. First is the variable, second is the constant, and third one is the power to those variables. We'll understand some of the important terms. So each part is separated by plus and the minus. So which means that each part is treated as a term here. So 3x to the power 2, 5x and 7. These are the three different terms which we are going to use, which we need to know when we are clearly defining a polynomial. We'll understand the concept of the coefficient. So what is the coefficient? So number multiplying the variable is the coefficient. For example, if we have 5x square, then coefficient is equal to 5. So what does coefficient means? Which means that it is a number which is attached to a variable, which gives a value to the variable. Or we understand that if variable is going to increase or decrease, then this coefficient is basically the multiplying factor to that particular variable, and that variable is going to increase or decrease. This is the number of times this coefficient is applied. Next important term is constant term without a variable, which means that in a particular polynomial equation, we have a constant term. For example, in this case, we have 7, and this is the constant term in a particular polynomial. So term, coefficient, and the constant term, these are some of the components and the important terms that we should be knowing for a polynomial. Next concept is the degree of the polynomial. So when we talk about the degree, what does that mean? So degree is the highest power in a particular polynomial. So degree with 1 is normally called as the linear equation. Degree with 2 is a quadratic equation, and degree with 3 is a cubic polynomial. Value of the polynomial is basically we have to derive the value of the polynomial by substituting a value of x in the given equation. For example, if let's say we have an equation 2x squared plus 3x plus 1, if we have to find the value, then we have to do a substitution method where we substitute the value of x is equal to 1, and then we'll get a value which is being aligned to that particular polynomial. The most important concept that we're going to understand is the zeros of a polynomial. Number k is a zero if pk is equal to 0. So what we have to do, we have to define the zeros, and to define the zeros, we have to do the factorization of the given polynomial. And when we do the factorization, we'll get the 0 to that polynomial. So we'll move to the next slide and see how this is done. Okay. Now, see, in this chapter, we are going to discuss extensively about the zero of a polynomial because we are going to understand this in bit detail because it also has a geometrical representation as well. So what is a zero of a polynomial? A number k is called a zero of a polynomial px if pk is equal to 0. So what we have to do? We have to equate the entire equation into 0 and then we have to factorize that equation to get the number of the zeros in that particular equation. Now, if we look at a particular equation type and we understood that linear polynomial is 1-degree polynomial, a quadratic polynomial is 2-degree polynomial, and likewise we have a cubic polynomial which is a 3-degree polynomial. Now, when we talk about degree 1, degree is also something which helps us to determine the zeros for that particular equation. So linear polynomial will have max to max 1 0 as an answer. For example, if an equation is there y is equal to ax plus b, and if we put y is equal to ax plus b and ax plus b is equal to 0, then we're only going to get this single value for that particular equation. So which means that it has the maximum of 1 0. So quadratic polynomial which is degree 2, if we equate the equation of ax square plus bx plus c is equal to 0, and then when we try to equate it and get the value, we'll maximum get two zeros. We'll have less than 2 as well, but the maximum 0 for a quadratic polynomial is 2 0. And when we try to represent this in the form of the graph, we'll get a parabola. So parabola is basically a graph wherein it's a U shape, it is a normal U or let's say reverse U shaped graph. When we try to plot this graph and it touch the x-axis at the maximum 2 points. So cut the x-axis 2 points, which is like 2 0, touches the x-axis at 1 0 and does not touch the x-axis is 0. So which means that maximum we can have 2 0 to a quadratic polynomial. There are two zeros can be a solution, 1 0 can be a solution, or there would be no 0 to solution. But we cannot have more than 2 0 for a quadratic polynomial. Likewise, for a cubic polynomial, which is ax cube plus bx cube plus cx plus d, when we equate this to 0, the maximum degree is 3, and likewise, it's a kind of an S-shaped curve, reverse S, or it's an S-shaped curve which is being formed, and it can have maximum of 3 zeros. 3 0 is the maximum. We can have 1 0, 2 0, as well as 3 0, which is the maximum. So with this, we clearly understand that how we have to derive the zero of a polynomial and then how these are represented graphically or geometrically. So we'll move to the next slide and see this in more detail. Now this is in continuation to the last slide wherein we were talking about the geometrical meaning for a zero. So we understood that degree of one polynomial will normally strive as a linear equation with maximum 0 of 1. Then we have quadratic equation with the maximum 0 of 2. And then we have a cubic equation with the maximum 0 of 3. So this gives us a clear direction that how many zeros are there for a linear equation, quadratic equation, or a cubical polynomial. So example, let's say we have an example wherein we are saying that we have x square minus 4 as one of the equation. This is largely a quadratic equation, but because we have highest degree of 2. And when we try to factorize it, we can factorize it with the formula a square minus b square, which gives us the value of x plus 2 and x minus 2. And then when we try to equate this to 0, we get two values, which is x is equal to 2 and x is equal to minus 2. So graph cut the x-axis at 2 0 and minus 2 0. So typically, when we have a board type question, and we normally get these kind of question wherein we need to understand or we need to tell how many zeros are there for a particular equation. So what we have to do, find the number of the zeros from the graph, identify the zero from the graph, draw the graph and verify the zero and match the polynomial values. These are like different multiple type questions that we normally get from the particular polynomials. We may need to we need to find the number of zeros from the graph. We identify the zeros from the graph, and then we also need to draw the graph basis the equation. So if you look at the rule here, if we have a linear equation with degree 1, the graph is represented by a straight line, which is like this one. This is a kind of an equation wherein we have a degree which is represented at 1, and this is a kind of a no turning point is there. So key feature it does not have a turning point. This is a linear equation and it will cut the x-axis at only 1 point. Then we have the U-shaped parabola, which is applicable to a quadratic equation or polynomial with 2-degree variable, maximum of 2 degree. So one turning point is there, which is a parabola here, which can be represented by this example, or which can be represented by this example. So which means that it is turning the x-axis at 2 point here, 1, 2 in this case, and it is also touching the x-axis at 1 point here, which is this case. Maximum is 2, but minimum can be 0 as well as less than 1, less than 2 as well. And then we have a S-shaped curve, which is specific to the cubical polynomial, which is being represented by this equation, which is represented by this equation, which is also represented by this equation. So which means that 3 is there and then 2 turning points are there. So if you look at it, we have 1, 2, 3, and then here is also we have 1, 2, 3 point here, which is being touched by the cubical polynomial, degree 3 polynomial rather. So if we look at it, the number of the polynomials, and in fact in the last example, it is turning the 4 polynomial, so which is a quadra polynomial here, which is more than a 3-degree polynomial, which is like 4-degree polynomial here. This is the fourth one here. And this is not being represented by 3. This is a 4 quadra polynomial. We'll call it as 4-degree polynomial. Okay, now we quickly look at the rules here. The number of the zeros are the if the number of the zeros is 1 is the graph that intersects x line at 1 point. Number of 0 is 2 as the graph intersects the x-axis at 2 point. This is the solution to all the 6 problem here. In the third solution, the number is 0 is 3. In the fourth solution, the number of 0 is 1. Fifth, the number of the 0 is 1. Sixth, the number of zeros is 4. So this is how we are going to identify the number of 0 from the graphical representation whenever we are having the graph which is given to us, and then we can derive the number of zeros on that particular graph. So we'll move to the next slide. Okay, now in the last slide we understood the concept that how we have to plot a particular polynomial, and we can identify an equation whether it is a linear, which is single, zero, quadratic, which is 2 0, cubical, which is 3 0, and the quartic, which is like 4 0. Now we'll understand that how we have to represent the same in the graphical representation. So a graph of a polynomial represents the relationship between the x and the y of a coordinate plane. So it helps us to visualize the polynomial, identify the zeros, which is the roots, and then understand the nature of the equation. So how we have to do, so this is a step-by-step presentation of how we have to plot a graph. So we have to choose the value for an x, and then we have to calculate the corresponding value for the y. So by putting the value for the x, we'll have the corresponding value for the y, and with that we can do the value mapping in the x-axis and the y-axis plane, and then we can construct a graph there. So graph of a linear polynomial is in the shape of ax plus b, which is a straight line. Key feature is that it exactly have the 1 0, cut the x-axis at 1 point. Graph of the quadratic polynomial, which is normally y ax square plus bx plus c, which is a normally parabola here. Cut the x-axis at 2 points, 2 0, touches the x-axis 1 0, does not meet x-axis 0 0. So which means that a particular polynomial with quadratic, which is a degree 2, which is ax square plus bx plus c, may cut the x-axis at 2 point maximum, touches the x-axis at 1 point can be, and does not meet x-axis, which means that we have an equation wherein both the values for a quadratic equation is 0. So we'll move to the next slide and look at the same for the cubic polynomial. Okay, so now we understood about the quadratic and linear. Similarly, we have a polynomial which is the cubical polynomial. So how we have to draw the graph is very, very simple. What we have to do, we have to create the x-axis and the y-axis here, and we are going to use those axes to create the graph. We'll create the x dash here, then we have the y and y dash here. Then we have to plot the graph here by putting the values of x, let's say 1 here, and then we have a 2 here. And on the negative side, which is the value, we have -1, and then we have the -2. And if we create a parabola here, that is something which is representing that it is touching the 2 points here, 2 here, and -2 here, -2 and 2 here, 2 points is a quadratic equation. And this is how we normally draw the particular graph for the equation that is being given to us. So we'll move to the next slide. Okay. So now we have understood clearly the concept of the zero. Now we need to understand the relationship between the coefficient and the zeros. This is very, very important. So we have a quadratic equation which is ax square plus bx plus c. And if its zeros are alpha, if we assume that there are zeros are alpha and beta, there exists a direct relationship between the zeros and the coefficient. And we are going to establish and use that relationship by identifying the values, because a quadratic equation is ax square plus bx plus c, where a is the coefficient to x0 and b is the coefficient to x, and then we have a c as a constant. So coefficients are there and it has a direct relationship between the zeros of the polynomial. So we have zeros which is being represented by the alpha and beta. We have two properties here, sum of the zeros and the product of the zeros. Sum of the zeros is represented by minus b upon a, which is the coefficient of x upon the coefficient of x square, and then we have a negative sign to it. And product of zeros is represented by c by a, which is the constant, and then the coefficient of x square, which is the a. So understanding the concept, these formulas connect the roots and the solution of the equation, and the coefficient are basically derived using the factorization method. So if we look at the verification example, we have an equation 2x square minus 7 minus 3. So how we have to derive 0? So to derive the 0, the step 1 is to we have to do the factorization and derive the zeros for that particular polynomial. So zeros are by during the factorization we have got the zeros 1 by 2 and then we have another 0 3. Then what we have to do? We have to establish whether the alpha plus beta and alpha beta are actually tallying with the zeros or not. So when we do the alpha plus beta, what we are doing? We are going to use the formula of minus b by a. So in this equation, our b was minus 7. When we apply minus to minus 7, it is going to turn to 7 here. And then we have a value as a 2. So 7 by 2 is the value which is being derived with the help of sum of the root, which is the minus b by a. And if we verify this alpha plus beta here, so what we are going to do, we have two zeros here, 1 by 2 and 3. And if we add the two zeros here, 1 by 2 plus 3, we'll get the value as 7 by 2. So which means that we have derived the zeros here, we have added those zeros, and then we compare that to added value of the zeros with the formula which is minus b by a. And if our minus b by a property sums up to the alpha plus beta, that means that our solution is correct. Likewise, we have two values here, alpha and beta. We'll multiply the value here, which is 1 by 2 multiplied by 3, which gives us 3 by 2. And then we'll compare it with the product of the roots, which is the c by a. If we derive the value c by here, we have 3 by 2 value. So 3 by 2 is tallying with the 3 by 2, which means that whatever values we have derived for alpha plus beta and alpha beta, they are tallying with the equation of the alpha plus beta, which is minus b by a, and it is tallying with the alpha beta, which is c by a. So alpha plus beta is equal to minus b by a, and this normally tallies with the sum of the zero, and alpha into beta, which is the product of the root, it is going to tally with the c by a, which is the product of my zeros. So this is the sum of the zero, this is the product of the zero, and we have to verify with this value with the minus b by and c by a to confirm whether our solution is correct or not. So we'll move to the next slide. Okay, so now we understood that we understand that what is polynomial. We understand that how we have to represent a particular polynomial on a graph. We have a linear polynomial, we have a quadratic polynomial, then we have a cubical polynomials. And then we also understood the concept of the sum of the zeros and the product of the zeros, and how they can be verified with the equation wherein sum of the zeros is equal to minus b by a, and minus b is nothing but the coefficient of x, and a is coefficient of x square, and c is constant. If we calculate the product of the roots, then we have c upon a as the formula. Now, what is a quadratic polynomial? So when we have to define a quadratic polynomial, we can construct that polynomial with the help of the sum of the roots and the product of the roots. So first we'll look at the quadratic polynomial here. So what we are saying here, quadratic polynomial is ax square plus bx plus c, where a is not equal to 0. If zeros are given, let the 0 be alpha and beta, then the quadratic polynomial is k multiplied by x minus alpha or x minus beta. And then the formal final equation is this one, which is x square minus sum of the roots, sum of the zeros into x plus alpha beta. So if in exam we have given the alpha plus beta, which is the sum of the zeros, and alpha beta, which is product of the zero, and we are asked to form a quadratic equation. We have to use this formula to derive the final quadratic equation. Step by step method is that we have to first identify the zero, which is alpha and beta. Then we have to write the factor x minus alpha and x minus beta. We have to multiply those factor and multiply by the constant k if required. And if we are simply given the values here, alpha plus beta and alpha beta, so either we can use the alpha and beta separately and use this equation to form the quadratic equation, or we can use this formula wherein we can first do the product and the sum of the alpha plus beta and alpha beta, and then we can create the quadratic equation with the help of this mechanism. So we'll move to the next slide. So we have understood the concept of zeros of a quadratic equation. Now we'll spend some time in understanding the concept of zeros of a cubic polynomial. So cubic polynomial is being represented by alpha cube ax cube plus bx cube plus cx plus c. So this is a normal representation of a cubical polynomial, and because it has three as the highest degree, then we have to introduce one more zero, which is gamma here. So it has three zero, and relationship is alpha, beta, and gamma, where alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha, this is basically the sum of the product. We could normally call it as the sum of the product. So we have the sum of the roots, we have the sum of the product, and then we have the product of the roots. So sum of the product is c by a, and then we have the product of the root, which is minus d by a. So we have to remember this. Here alpha plus beta plus gamma, sum of the root is largely the same formula. So in the quadratic equation we are having alpha plus beta, which is minus b by a. Here we have alpha plus beta plus gamma, which is minus b by a. Here the product of the root is different because product of the root is minus d by a, and in the quadratic equation it was c by a. So here constant is equal to d, and their constant was c, and hence the equation was c by a in case of the quadratic, but in case of the cubical it is not d by a, it is minus d by a. So this is the point we need to remember. And then we have another concept here wherein we are talking about the sum of the product, which is being represented by c by a. So if we have given this value, we have to use this value to create the polynomial for degree 3. Now we'll move to the exercise and look at some of the questions that are there in the NCERT exercise. Okay, so this is the exercise 2.1, which has certain set of the graphs, and we are asked to identify the number of the zeros for each of them. So if you look at the first one, it is not touching any of the x-axis, so we do not have any zero for this. Then we have another graph herein we can see that it touched the x-axis at 1 point, and hence for this we have 1 0. And here if you can see it is touching the x-axis at 2 point, or let's say the 3 point here, and hence we have zeros as 3 here. So in this next equation we have 2 points, which is largely a parabola, which is cutting the two points here. So this is 2 point here, and then we have the 4 points, and then we have another 3 point. So if we have to classify this equation, this is our understanding that we have developed till now. So first equation is not an equation, it's not a linear equation, because linear equation has to cut one of one, and we can definitely define as a linear equation because it's a straight line, though it is not touching, so we can call it as a linear equation. Second, it's an S curve here, so we can classify it as a cubical. Next, we have another S curve here, we can classify it as cubical. Then we have parabola, we can classify it as a quadratic equation. Next, we have again a S kind of a curve, which is calling as a cubical or quadratic, and which is more than 4, so we can call it quadratic, not quadratic, it's a quadratic. And then we have 3, which is a cubical representation. So this is how we can represent a particular graph and understand the concept of zeros to identify how many zeros are there in the particular graph. So we'll move to the next slide. Okay, now we'll try to resolve some of the examples and understand, some of the practical understanding of the sum of the zeros and the product of the zeros. So we'll go for each example. So find the zero of a quadratic polynomial. We have given a quadratic polynomial. We have to find the zero, and then we have to develop the relationship. So what we have given an equation. Here a is equal to 1. X square, the coefficient of x square is 1, coefficient of x is 7, and constant is c. So a is equal to 1, b is equal to 7, c is equal to 10. First of all, we have to identify the zero by doing the factorization of this particular equation, and we have zeros as -5 and -2. Then we'll do the sum of the 0 by doing the alpha plus beta and compare this value with minus b by a, and we have the value of a and b given to us, and if the values are same, then we assume we conclude that this equation has the right set of the zeros which is being tallying with their main equation. Likewise, we have the alpha beta, so wherein we have to identify alpha and beta. We have minus 5 and minus 2. We'll multiply the alpha with the beta to get the product as 10, and then we'll compare with the c by a. So we have c as 10 and a as 1, so 10 by 1 is equal to 10. So this is how we have to solve the particular question if it's being given in a question, and we have to solve this question like this method only. So each step has a value, has an importance. So we have to make sure that we have to follow the step-by-step approach to solve a particular question. So we'll move to the next slide. Okay, so we have another example here. So we have to find the zero for this particular equation, x square minus 3. So we'll recall the identity a square minus b square, break the equation into a square minus b square, and we have the values x plus root 3 and x minus root 3. So we have two zeros, root 3 and minus root 3. And example 4 is there, wherein what we have to do, we have to find a quadratic polynomial, and we have given the sum of the roots and the product of the roots. So we'll use the simple formula, x square minus sum of the root into x plus product of the root. So x square minus is in the formula. We have the sum of the root as minus 3 multiplied by x, and then we have the product of the root. So x square minus minus become positive. So our equation is x square plus 3x plus 2. So this is how we have to solve the problem whenever a particular sum of the roots and the product of the roots are given to us. So we'll move to the next slide. Okay. Now we are going to have another example. We're going to talk about another example. This is the cubic expression here. So we have values, three zeros are given to us, 3, minus 1 and minus 1 by 3 are three zeros of a cubical polynomial. And then verify the relationship between the zeros and the coefficient. So this is same example, but now we have a cubical polynomial rather than a quadratic polynomial. So equation given is 3x cube minus 5x cube minus 11x minus 3. So alpha is given as 3, beta is given as minus 1, and gamma is given as minus 1 by 3. So what we have to do, we have to check first whether these are actually the zeros of this particular polynomial or not. So what we have to do, we have to substitute a value 3 in this equation. We'll do that. We identify it as 0, so which means that this 0 is correct. Then what we have to do, we have to check the balance for minus 1 as well. We put the values of minus 1 in this equation and verify whether this 0 is coming or not. And then we have to check for minus 1 by 3 as well. So when we put minus 1 by 3, we again get the value as 0 here. So we have done that, checking that at least 3 minus 1 minus 3 are the zeros of a cubical polynomial, 3x cube minus 5x cube minus 11x plus 3. So this has been verified. And then what we do have to do, we have to verify the relationship between the zeros and the coefficient. So which we have done. We'll move to the next slide and see that verification. Okay. So in the previous slide, we verified the three zeros for a cubical polynomial. Now we are going to verify the relationship between the coefficient as well. So we know that sum of the zero for a cubic polynomial is alpha plus beta plus gamma, which is b by a. So we'll first, what we do, we'll do the sum of the three zeros. 3 plus minus 1 plus minus 1 by 3. We got the values 5 by 3. And when we compare this with the value in the original equation, our value is b minus b by a. We have the minus b as the minus 5, and we will apply with minus, we have the 5, and then 5 by 3 is the value. So this value is tallying with the sum of my zeros. So which means that coefficient relationship with the coefficient with the 0 is tallying. Second, what we have to do, sum of the products. So what we have to do, we have to calculate the alpha beta, beta gamma, and gamma alpha. So alpha into beta, beta into gamma, and gamma into alpha. We have to add that value, and then we'll get the value which we need to see whether it is tallying with the C by A. So this value is tallying with the C by A. So minus 11 by 3 is the sum of the product, and this is tallying with the minus 11 by 3, which is my C by A. And then we have to understand the product of the zeros, which is alpha, beta, and gamma. So if we multiply 3 into minus 1 by 3, we get the value 1. And when we compare this value with the minus d by a, it is also coming as 1. So which means that our zeros, first we have verified whether these zeros are applicable for that particular cubic polynomial or not. So we have identified that, and then we have to apply the formula to identify whether the coefficient relationship is telling with the actual equation or not, and which we did by verifying that the sum of the zero, which is minus b by a, sum of the product of the zero, which is c by a, and product of the zero, which is minus d by a, is tallying with the actual values that we have been given. So with this, we'll move to the next slide. Okay, now we're going to talk about the exercise 2.2, wherein we have solved all the questions and CRT questions here. So what we have to do in this, we have to find the zeros of the following quadratic polynomial, verify the relationship between the zero and the coefficient. So we'll apply the same logic here. So we have a given equation. So step one is we have to first break that equation by the factorization, and we have to calculate the zero. So we have verified that we have got the two zeros here, 4 and minus 2, and then we apply the with the formula. We'll evaluate the alpha plus beta and alpha plus beta and compare it with minus b by a and c by a to confirm that our equation is telling or not. So each of the formula we have to do the same method. So the next equation, again we have to first solve the equation by the factorization, derive the zeros, and then we have to adopt the alpha plus beta and alpha beta, and to compare the value with the minus b by a and the c by a, and likewise for the third equation as well. So this is the same method that we have used in earlier examples, and we have clearly demonstrated it. We have to use the same methodology for each of these equations. So we'll move to the next slide. So this is the rest of the three question from exercise 2.2, and again the concept is same. We have to derive the zeros with the help of the factorization method, and then we have to apply the logic here of identifying the alpha plus beta and alpha beta, and then comparing it with the sum of the root by minus b by a and product of the root with the c by a, and then we can able to establish whether these equations are having correct values and the zeros and the coefficient. So this is the same set of the examples or the equations that we have considered, and the method is absolutely the same. So we'll move to the next slide. Okay. So in this, what we have to do, we have to form a quadratic equation wherein we have given the sum of the sum and the product of the respective polynomials. So we have given the two roots. We have given the sum of the zero and then product of the zero. So for find a quadratic polynomials with the given number as the sum and the product of the zero respectively. So we have given a sum as 1 by 4 and product as minus 1. What we have to do, we have to simply substitute that value in this equation. So x square minus sum of the roots into x, or sum of the zeros into x plus product of the zero. So sum is 1 by 4 and product is 1. We'll solve the equation here. Likewise, the sum is root 2, product is 1 by 3. We again create an equation, solve it here. Sum is 0, product is root 5. So for 0, we do not have any value. So we do not have any coefficient for x then. So we have the equation x cube plus 5. Similarly, we have solved another two question in the next slide. So move to the next slide. Okay. So if we look at it, we have another two question, which is sum 1, product 1, sum 1 by 4, product 1 by 4, and sum 4. So typically the logic here is that we have to apply the same logic x square minus sum of the zeros into x plus product of the zeros to derive the quadratic equation. So with this, we actually come to the end of this chapter, and we could able to understand the concept of the polynomial, the degree of the polynomial, how it can be presented on a graph, what is the geometrical representation of a polynomial, then how we can verify the relationship between the zero and the coefficient by establishing the fact, and then we can how we can form a particular equation when we have given the sum of the roots and the product of roots. So with this, we'll come to the end of the chapter. Let's move to the final slide and look at some of the key takeaways. Okay, so some of the key takeaways or some of the points to remember is that the polynomial degree 1, 2, and 3 are called linear, quadratic, and cubic polynomials. So we are going to restrict our discussion till cubic only. Quadratic polynomial is x with the real coefficient is ax square plus bx plus c, where a, b, and c are the real number and a is not equal to 0. The zero of the polynomial is precisely the x coordinate of the point where the graph ypx intersect with the x-axis. Quadratic polynomial can have at most 2 0, and cubical polynomial can have at most 3 zeros. Alpha beta are the roots of a quadratic polynomial, wherein alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. And for a polynomial with degree 3, which is the cubical polynomial, alpha plus beta plus gamma is equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. So remember this point to make sure that whenever you get the question, you attempt it correctly and solve it correctly. So with this, we'll come to the end of this chapter, and we'll come up with a new chapter on the linear equation in two variable very soon. Thank you for watching this video.